All right, so this is our next little topic here. I want to start off by sort of running through this problem I have worked out for us, and then we're going to use this as the impetus to look at our new topic. So we've been given a population, a normally distributed population. So all the work we're doing for now, everything is normally distributed. We've been given the mean is 24, the standard deviation is 2.5. We've been asked to find the probability that x is less than 20.8. So this is straightforward, this is standard, the same as the homework we've been working on for the previous section. Now, it's important to bear in mind what it is we're given and what it is we want to find. So here's my picture. Mean is 24, standard deviation 2.5. Here's the 20.8. We've been given a value on the x scale. Remember, this is the x scale, this is the z scale. We've been given a value on the x scale, and our goal is to find this probability with which it's associated, the probability that is less than the number in question. All right? Remember the procedure. 20.8, we're going to standardize, use that to find the z-score, take the z-score, use that in the table to find the table value, and then once we find this value, this is what we're looking for. All right? So here's the guts of it. There's the standardized, so now we're moving from the data scale to the standard scale, 20.8 minus 24 over 2.5. That works out to be negative 1.28, so I can put that in the picture, negative 1.28. All right, so what's the next piece? The next piece is use that and the standard normal table to find the table value, which in this case is 0.1003. Remember, that number goes on this line, 0.1003. So given this value, work your way up the mountain to find this probability, 0.1003. So what we have is the probability x is less than 20.8 is 0.1003. We may, if we wish, we may rewrite that or reconsider that as 10.03%. And 10.03% is approximately equal to 10%. So what we can say is 10% is approximately corresponds to the probability that x is less than 20.8. All right? So what we're going to do is this. Suppose we have a normally distributed population. Suppose we're given the 10%, and our task is to find, we want to find that value, all right? Suppose we're given the final result we're looking for. Suppose we're given the 0.1003, and we want to find what value here will yield this value. What value here will yield this value we're looking for. All right? Or, more to the point, what value here will correspond to the 10%. If you're given the 10% or the 0.1003, the question is, what number does it correspond to? All right? So, given the final result, we want to work our way up the scale to find what is the x value that will give us the 10% we were given to start with. All right? So, here's the normal curve we're working with. This is this is the standard scale. This is the data scale. This was centered at 24. All right? And so, suppose we're given the final result. Suppose we're given this 10%. Suppose we're given that this is 10% of the population. Now, what does that correspond to as a decimal? Given 10% here, that corresponds to the 0.100. Now, 0.1003, we've rounded that to 10%. Suppose we didn't want to round. Suppose we were satisfied with the 0.1003. Suppose we're satisfied with 0.1003, and the question is, what is the value here that this corresponds to? Suppose you're given this result and we want to find the value it came from. Here, you're given the value on the x scale. You want to find the probability value it corresponds to. Here, given the probability value, 0.1003, we want to work backwards to find what x scale value that came from. Well, we know how that works. Where did this come from in the first place? This came from the value in the table, which arose from the z-score. Remember here we had the 0.1028 as the z-score, and we looked on our z-score table. We had negative 1.28, and we looked in. We started here and worked in to find this 0.1003. Now we need to do that process backwards. We need to find this number in the body of the table and then look outward to see what z-score it would have come from. Imagine running the movie backwards. If we start here and zip in to find the 0.1003. Now when you run the video in reverse, you start here and you look outward to see what z-score it would have come from. So given this value, find this number in the body of the table. And then look outward to find the z-score. In this case, that would have been, of course, the same negative. This value, this is the 0.1003, but these two values give us the negative 1.28 that we're looking for. That is the z-score. Remember, these values are z-scores out here on the margins. So we have now the z-score. And the question, so this is the negative 1.28. Notice we're working our way back down the hill. We started here, now we're working our way back down. The last piece of the puzzle is, how do you find the x value from which this came? Well, we use the same z-score or formula, x minus mu over sigma. However, do you see what happens? Now we know mu, we know sigma. That must have been given at the very start. But now we know z and want to find the value for x. So this implies that we know negative 1.28 is equal to, don't know yet, minus mu was given to be 24. Sigma, standard deviation, was given to be 2.5. Every time you do this problem, you'll do this. You'll put this over 1, cross multiply, set equal. Every time you do this problem, you'll take the z-score is equal to this expression, cross multiply and solve. Cross multiply, x minus 24 times 1 is x minus 24, is equal to cross multiply negative 1.28, 2.5, and then solve that. Hopefully you can speak that much algebra. Solve that. So let's see, I have negative 1.28 times 2.5. That's negative 3.2. And then do we see what happens? You add the 24 to the other side. So if you 24, if you add 24 to that value, we end up with 20.8. And sure enough, that's exactly the process number we would have started with up here. So this procedure is the reverse of this procedure. Here, given x, find probability. Here, given probability, find x. That's the procedure. Now, there are a few little quirks and nuts and bolts and techniques to work with, but that's the basic idea. And so if you need to look at this again, make sure you can understand the basic idea, and then next we'll talk about the specific details of how do you run this through if you don't have this problem already present.